Welcome back, everybody. Okay, you had a practice sheet on solving a system of equations using the addition method. If you didn't get to work on it, pause the video, try the problem. When you're ready, press play and see if what you get matches up with what I had. Okay, here's the first problem. X plus y equals 4. X minus y equals 6. Okay, now, notice when you look at the two equations, everything's lined up. All the x's are lined up, the y's are lined up, the equal signs are lined up, the answer numbers are lined up. Okay, so when we add straight down in the columns, hopefully one of the variables disappears. So when I add this column, the x's come out to 2x, the y's, they cancel, equals 10. Okay, now we just solve for x. Divide both sides by 2. The 2's cancel, so x equals 5. Now that we know what x is, we take that answer, put it back into one of the original equations in place of x, and then we solve for y. So I'm going to take the first equation. In place of x, I'm going to put the 5 plus y equals 4. And now we get y by itself. We need to get rid of the 5. So I'm going to subtract 5 on both sides. Y equals -1. And there you go. That is our solution. Okay, let's try the next one. The second problem. -6x plus 5y equals 4. And then 3x plus 4y equals 11. Now, when we add straight down, one of the variables has to disappear. Yeah, if you look at this, -6 and 3, that won't cancel. 5 and 4, they won't cancel if I add straight down the 4. And so we need to somehow get it so that the variables match. Okay, now I'm going to get it so that the x variable, the coefficient, is going to be the same. We could do it for the y variable. I'm just going to do it for the x for now. Whichever one we solve for, it's going to come out to the same answer. So we need the -6 and the 3 to be the same. I can change the -6 and the 3. They can both become 6. Yeah? All we gotta do is get that 3 to change. So I'm going to multiply this equation by 2. So the top equation will stay the same. -6x plus 5y equals 4. This bottom, if I multiply everything by 2, that'll give me 6x plus 8y equals 22. Now, if I add this column together, the x's will cancel because the 6 and -6, they're opposites. I just add the rest of the columns. So this will give me 13y equals 26. Now that we have only one variable, we can solve for the variable. Divide both sides by 13, so y equals 2. Okay. Now that we know what y is, we can put it back into one of the original equations and solve for x. So I am going to take the second equation and replace y with 2. So 3x plus 4, and in place of y, I'm going to put the 2. Now, we just got to solve for x. 3x plus 8 is equal to 11, and then we try to get the 3x by itself. We're going to subtract 8 on both sides. 3x equals 3, and now we get x by itself. We need to undo the multiplication. Divide. X equals 1. And that's your solution. Now, we could have solved for y instead. So here, I'm going to do this again. I'm going to write the same problem. Negative 6x plus 5y equals 4. 3x plus 4y equals 11. Okay, instead of doing x, we're going to do y instead. We need to get the y numbers, the coefficients, to be the same, but with different signs. We need them to be opposites. Can you think of a number that 5 and 4 can become? We can change them to 20. Yeah, one of them has to be a positive 20, the other has to be a negative 20. Okay, so that way they can cancel each other out. We are going to take the first equation. Let's get this to be a 20. We're going to multiply the top equation by 4. So that'll give us a negative 24x plus 20y equals 16. Now, if that's a 20, we need to make the bottom equation for a negative 20. So we should multiply that one by negative 5. So we multiply everything by negative 5. That'll give us a negative 15x, negative 20y equals negative 55. Now, if we add straight down in the columns, the y's will cancel. That'll leave us with just one variable. So if we add the remaining columns, this will add up to negative 39x, and on this side, negative 39. Okay, now we just solve for x. We need to undo the multiplication, divide both sides by negative 39, x equals 1, which is what we had when we did the problem the previous time. See, so if we stick it back in, we should get the same answer. So it doesn't matter which variable we're solving for. Yeah, we just need, well, not solving for, but it doesn't matter which variable we eliminate. We just need to eliminate one of them. Yeah. Okay, next problem. 2x plus 3y equals 23. 3x plus 5y equals 37. Okay, I'm not going to solve for both variables like the last problem. I'm just going to pick one. You can choose whichever one you want, but for those of you that want to stick together, I'm going to get rid of x. So look at the 2 and the 3. We need to change them so that they're the same number but with different signs. We need them to be opposites. I can change them to 6's. Yeah, there are other possibilities, but I can change both of these numbers, the 2 and the 3, to become 6 and negative 6. Okay, so in order to do that, I need to multiply the top equation by 3. So that'll give me 6x plus 9y equals 69. On the bottom, I need that x to become a negative 6 because this one is already positive if I want it to cancel. So for that to become a negative 6, I'm going to multiply by a negative 2 to every single term. So negative 6x, a negative 10y, and a negative 74. Okay, the x's are going to cancel now. They're opposite signs. If I add the remaining columns, this will give me negative 1y equals, if I add that, that's a negative 5. If I divide both sides by negative 1, y equals 5. We take the 5 now, and we're going to replace it back into one of the equations. Let's see. I'm going to use the bottom one. It doesn't matter which one, just pick one. It's supposed to work because it's a system. So I'm going to take the bottom equation, 3x plus 5 parentheses, and in place of y, we're going to put the 5 that we just got, equals 37. And then we solve for x. We need to get rid of the 25, so subtract 25 on both sides. 3x equals 12, and then we need to undo the multiplication. Divide both sides by 3. X equals 4. For those of you that solve to get rid of y first, you're supposed to get the same answers, 4 and 5. Yeah? Okay, one more problem. Number 4. Number 4 says 4y plus 8 equals 5x. The second equation, 2x minus y equals 5. Okay, the difference with this problem and the previous three is not all lined up very nicely. So we're going to have to do some manipulating. I'm going to try and make it so that it looks like the bottom, where the x's and the y's are on the same side, the answer number is on the other side, on the right. Okay, so I'm going to take that top equation and I'm going to manipulate. So let's see, that 5x has to go on the left, and then the 8 has to somehow end up on the right. Okay, so in order to get the x and y on the same side, I'm going to move the 8 to the other side. So I subtract 8 on both sides. Now I have 4y equals 5x minus 8. So now we have the answer number on the right. All we got to do is get that 5x on the left. Subtract 5x on both sides. Negative 5x plus 4y equals negative 8. Now I can write the other equation directly below it, and everything's going to be lined up in columns. So right underneath, I'm going to write 2x minus y equals 5. Everything's nicely lined up. We are going to get rid of one of the variables. Okay, last time we got rid of x. This time we're going to get rid of y. We need to get the y coefficients, the numbers in front that are being multiplied, to be the same number but with different signs. There's a number there, you don't see it, but it's there. It's a negative 1. So we want these two numbers, the 4 and the negative 1, to be the same number. Already the signs are different. I should multiply this bottom equation by 4. The top equation will stay the same. Negative 5x plus 4y equals negative 8. The bottom equation, if I multiply by 4, I'll get 8x minus 4y equals 20. Notice the y coefficients, 4 and negative 4, they'll cancel each other out. If I add the remaining columns, 3x equals 12. And then I solve for x. Once I know what x is, I put it back into one of the original equations and I solve for y. Since I used the second equation, I'm going to use the first one this time. It doesn't matter which one you put it into. It's supposed to work because it's a system of equations. It works for both equations. So I'm going to take the first equation and replace x with 4. And now I solve for y. Okay, I'm going to get rid of the 8. Now we have 4y equals 12. Divide both sides by 4, y is equal to 3. Okay, hope that helped. We'll see you in the next one.